Hey everyone, in this video we are going to be learning about how to calculate the volume of pyramids and cones. First, let's start off with some notes. So a pyramid is a 3D shape that has one base, and that one base could be a variety of different polygons. It could be a square, it could be a triangle, rectangle, and so on. Whereas a cone has one base as well, but that base is going to be a circle. We're only going to work with right circular cones here. The volume formula for a pyramid is 1/3 capital B times H. That capital B stands for area of the base. It is important that that's capital, and H is the height. Now, since a cone is very similar to a pyramid, it's also the same volume formula. However, since all of the bases of the cones we're going to see are circles, instead of using capital B, we could replace it with pi r squared, because basically capital B, area of the base, is pi r squared whenever the base is a circle. All right, so let's grab our calculators and let's start to look at some sample questions. And actually, before we do that, just one quick note. It says here, both pyramids and cones have a vertical height and a slant height. If given the slant height, use Pythagorean theorem to find the vertical height. So we'll look at that in our sample questions. All right, so let's grab calculators, and we are going to need them in order to calculate our volumes. So let's start with one here. Find the volume of the rectangular pyramid. So I'm going to start by just writing down what my volume formula is. The key is that it says it's a rectangular pyramid. That tells me the base is a rectangle. And to find the volume of rectangle, I'm going to do length times width, so 8 times 3 in this case. The height of the pyramid is 12. So I'm going to put this into my calculator. So 1/3 times 8 times 3 times 12. And I got that the volume of the pyramid is 96. Whenever we find volume, our units are cubed, so centimeters cubed. Number 2, find the volume of the cone in terms of pi. So I'm going to use our shortcut formula for finding volume of cones, the one that has replaced capital B with pi r squared. And now I can just substitute in our values. We can see the radius is 5, and we can see that the height is 9. Now, since this problem says in terms of pi, what that means is we want pi to be in our answer, and that means we do not want it typed into our calculator. So I'm going to type in my calculator everything besides the pi. Okay, so the 1/3 gets typed in, the 5 squared, the 9, and I get 75. But our answer, since it's in terms of pi, will be 75 pi centimeters cubed. The reason this is done is so that we don't have to round. If you think about pi, it's an irrational number. You're going to get a decimal every time. This gives us an exact volume of the cone. Okay, number 3, a hexagonal pyramid has a base area of 42 inches squared and a height of 6 inches. Find the volume of the pyramid. So our volume formula again, 1/3 capital B times H. We don't need to know how to find the area of the hexagon here. It just tells us that the area is 42 and the height of the pyramid is 6. So we just now have to type that into our calculator. So 1/3 times 42 times 6, we get 84, and our units are inches cubed. Number 4, the square pyramid shown below has an altitude of 9 and a base with edges of 7 inches. Find the volume of the pyramid. Here's our formula again. Area of the base, well, this is a square base. I know that because it says square pyramid. So all the sides are 7, so I would do 7 times 7 in order to find the area. And the height of the pyramid is 9. Once we have all of that filled in, again, we go to our calculator, type it in, and I get the volume of the pyramid is 147 inches cubed. Number 5, find the volume of a right circular cone with a diameter of 6. Keep in mind that means our radius is 3. And a height of 14 inches rounded to the nearest hundredth of a cubic inch. We're going to use that shortcut formula of the 1/3 pi r squared H for our cone. The radius is 3, height is 14. We are putting pi in the calculator because it does not say in terms of pi. Anytime you're going to round, that's when you are going to put pi in the calculator. So 1/3 times pi times 3 squared times 14. And we're rounding to the nearest hundredth, so 2 places past the decimal. That gives me 131.95 cubic inches. Number 6, the isosceles triangle shown below has a base of 12 inches and a height of 5 inches. If the triangle is continuously rotated about its altitude, what is the volume of the 3D object formed by this rotation in terms of pi? When you're forming a solid of revolution, which is what we're doing in this case, the way you would draw it out is almost by thinking of a reflection. If I take A and reflect it over the altitude in this case, it's going to land on C. If I take C and reflect it over the altitude, it's going to land on A. And what's going to happen is it's going to basically just map onto itself. Now we know we need this to be a 3-dimensional shape. So whatever edge is perpendicular to the axis of rotation, that would be AC, we're going to curve it. And now you can see that this resembles a cone. So let's use our cone formula. 1/3 pi, the radius is 6. Notice how the diameter of that cone is 12, so the radius is 6. The height is 5. We're looking for this in terms of pi, so I'm not putting pi in my calculator. I'm putting everything else. And I get that the volume is 60 pi cubic inches. Number 7, a right circular cone has a volume of 12.5 pi meters cubed, diameter of 5. Keep in mind, radius is 2.5 then. Find the height in meters. All right, so this one's a little bit reversed. So what we're doing in this case is we're actually given the volume. So I'm going to plug that in for V. And we're asked to find one of the dimensions. So in this case, we are going to be solving for H. What I would suggest doing is if that volume is in terms of pi, which it is here, get rid of pi first. It's going to cancel out on both sides when you divide by it because you'll get pi over pi, which is 1. So I'm just going to get rid of it right to start. And I'm also going to get rid of the fraction. The way I'm going to do that is by multiplying both sides by the reciprocal. So 3 times 12.5 is 37.5. Over on the right, the 1/3 and the 3 will go away. And then I'll simplify the 2.5 squared. Now you can see we have a much simpler equation to solve. Divide both sides by 6.25. So 37.5 divided by 6.25, and we get 6 meters as our height of the cone. All right, last problem here. The pyramid shown below has a rectangular base with dimensions 12 by 2.5. If the slant height of the pyramid is 10, what is the volume of the pyramid? So I mentioned before that if you're given slant height, you're going to need to use Pythagorean theorem. So here's my right triangle. If it helps, draw it off to the side. The hypotenuse is 10. The bottom leg is 6, because notice it's half of 12, and we're looking for this missing leg here, or the height of the pyramid. And I could use Pythagorean theorem or know my Pythagorean triples, and I'm going to get that that value is 8. Now that I have that, I can go about my formula, 1/3 capital B times H. Area of the base is going to be 2.5 times 12, since it's a rectangle, length times width. The height is now 8, and we are going to put that in our calculator. So I have 1/3 times 2.5 times 12 times 8, and we get the volume of this pyramid is 80 inches cubed. Hopefully this video helps you understand how to calculate the volume of pyramids and cones.